Hello and welcome to the QA Underground. Today we're going to continue our video series on AI and testing and give a brief overview of what reinforcement learning is and how it can be applied to existing automation frameworks. In our previous video, we covered convolutional neural networks and how they can be integrated into existing automation frameworks. So first off, we're going to give an overview of what reinforcement learning is. Reinforcement learning really takes the concept of having an agent in an environment. And inside that environment, the agent has what's called a state and an action. The state being where the agent is currently within the environment, and the action being what the current actions are available to that agent within the environment. So to dive deeper into what states and actions are really the inputs for that agent. So what is the current status of my agent? Where is he currently located? Actions are, again, the actions that are available to the agent in its current state. And when you combine the two, state and action, you can actually calculate what's called a Q function. And that Q function calculates a Q value. And using that Q value, the agent can determine what the best action to take in its current state. When looking at reinforcement learning, you really need to ask yourself, what is the end goal here? And the goal with reinforcement learning is really to take actions that result in the maximum reward value. So what is the best action that I can take that will get me closer to my goal? So for example, if the agent takes a certain path through the application under test, it can arrive on a certain page. So we're going to take a look at the grid world example. So the goals here is to find the star. So we have our agent that's currently in coordinates 3, 1, and we need to find the star, which is currently in coordinates 1, 9. So when I'm talking about state in this example, I'm talking about what the agent's current state is or what the agent's current coordinates are. And the actions available to that agent would be moving right, left, up, and down. So as we move through the grid, we'll actually hit some special details. So we have these walls that are here that will be blocking our agent from getting to the star. So when the agent reaches those walls, we will need to apply a negative reward so the agent doesn't hit the wall and moves around it. So as our agent moves through the grid to get to the star, each action the agent takes will be assigned a reward. The higher the reward, the closer the goal. The lower the reward, the further away from the goal. So how do we use reinforcement learning for testing? The standard way currently is to use reinforcement learning for testing all combinations and all paths to the end goal. So why would we do this? The main reason would be to find all the paths to the goal, right? So we would take all the positive paths that lead us to the goal and all the negative paths as well. And the output that we get from this is really allowing us a number of things, but the main thing that will be utilized out of here is finding the least amount of steps to the end goal. So what is the fastest route to the star? A few uses for this are obviously that we are able to find the most efficient number of steps to the end goal, aka the fastest way to the goal. But we can also generate test cases that cover that peripheral testing. So all the paths that would be outside of the scope of the tester to look at, but may also contain bugs and other issues. Additionally, what's really cool about reinforcement learning is that you can also use the RL model that we generate and use for our testing in other areas of the business outside of QA. Because we have this model that can really be looked at as a end user. And that end user model can be utilized in other aspects of the business, like analytics, etc. So a common way that we would do this is that we could utilize a common utilities method or an assertion. And inside that assertion, we can pass an expected value and an actual value. And those expected values is the reward that you're getting for each action that you're taking and what reward you're expecting to get. We can pass a failure message in here. So if the reward isn't what we expected, we can pass that. We can be notified. We also pass to this assertion the amount of reward we want to give the agent if it passes. So if it takes an action that is a positive action, we can then apply a reward that's positive. If the agent takes an action that calculates to a negative Q value, then we can pass a negative reward to that agent. I want to give a quick example of a comparison between the star example that we're talking about and an application under test. So in the star example that we gave, it was a grid value, right? So a pretty straightforward, not realistic example. So we have coordinates on a grid and we have our end goal, which is the star. And as we move through the coordinates, we figure out what the most efficient path through that grid to the star will be. When looking at the application under test, it's very similar. So instead of coordinates, we'll have web pages, right? So for an e-commerce site, we would have a login page, home page, item page, cart page, etc., until it gets to our goal, and in this example would be the checkout page. So as it moves through those pages, we assign rewards to it when it gets to pages that are closer to our goal. And as it gets further away from our goal, we assign negative rewards. So you can really see that we can start to generate test cases that have very efficient workflows that allows us to go from one page to our goal, which would be in this scenario a checkout page. And we can also look at scenarios that are outside these bounds. So this isn't obviously the only route that this agent can take that can get us to the checkout page. So we can also generate test cases that include that peripheral testing. And as we generate these test cases, we would then have a suite of test cases that are generated that allow us to test all combinations of the workflow that gets us to that checkout page. So as you can see, reinforcement learning can be a powerful tool in terms of test generation and can be looked at really increasing your code coverage and covering that peripheral testing outside of the scope of a current feature. I want to thank everybody for joining me during this video. Please like and subscribe to the channel, and I hope to see you in the next video.